The CUBE project is BCIT's 3D Simulation Development Lab. It's a new venture for us in partnership with Lockheed Martin and others, and we are looking to develop some 3D learning objects that will help us enhance our curriculum that we develop to students.
The projects that we partner with instructors to develop in the CUBE address a wide range of learning outcomes and support instructors and students in a variety of programs at BCIT. One of the most basic learning outcomes addressed is the ability to help students visualize something with interactive 3D models and simulations. Our 3D animations enable students to visualize movement through specific mechanical parts like the flow of oil through a controllable pitch propeller at the back end of a ship, or the firing of electrons inside a CRT monitor. This is something you can't emulate in a lab or a workshop setting because it's either too dangerous or simply impossible. Our projects go beyond enabling students to visualize hidden or complicated elements. Our projects also address learning outcomes that allow students to practice the assembly and disassembly of parts, like that of an aircraft engine with our PT6 model. Students can practice these assembly and disassembly tasks at any time or any place over and over again.
Most of my students are in their early 20s and they're used to playing with video games and animation, so it's a media they're really comfortable with, and they can adapt to it pretty readily, so it works.
It's such a useful tool when you're learning the engine or you're learning any parts. And I know one of my friends who went through this program before, they did it with landing gear.
Very easy to use, very thorough, very, very detailed. I would have to thank the animators for making it so completely just identical to the PT6 itself.
I think the advantage of 3D is really that from a student's point of view, they get to see all the parts pretty much as they are in the real world, but in a virtual environment. They can play with them, they can familiarize themselves with them, they can do virtual assembly and disassembly procedures, and they can do it time and time again, and there's no danger of anything getting broken or anyone getting hurt.
From the academic perspective, using 3D technology, it's forced us to reevaluate some of the depth that we can teach things at in the classroom. Ability to rotate and to move it through the range of motion in the knee, for example, has really allowed us to get a little deeper into the content.
The Royal Oak Avenue Bridge is about a bridge that is in easy walking distance from campus. The students can go and actually have a look at it, and then once they've had a first look at it, then we can talk about the construction methods involved in that particular bridge. What I came up with was an idea to create a three-dimensional model that you could click on that would be tied into the specific photos that apply to that particular element. I thought initially that I could do that myself, but then I realized that it would take a lot more resources, and that's where the CUBE came into it. So I approached the Learning Center and said, this is my idea, how would I go about it? And then the relationship developed from there.
Our learners are changing. They're seeing lots of YouTube animations. There's so much interactivity, and the expectation is that they're coming into an institute of technology like BCIT or an institute of higher education, and they expect that interactivity to carry on. So the 3D Heart program is a virtual representation of an actual heart that the students can manipulate. We have concepts that we use in our practice called the oxygen supply and demand framework. And we need a way to visualize the way the heart works, and the 3D Heart project allows the students to manipulate that and see what the heart really actually looks like.
The instructor's role is to provide the ideas and the knowledge that they have, and that knowledge gets passed on to us, which we develop into 3D simulation. Currently, there are several key members in the CUBE, consist of instructional designers, 3D modelers, graphic artists, and multimedia developers.
One of our main goals is to help instructors create a safe learning environment where students can view, manipulate, and interact with models of heart, engines, turbines, and roof frames, and even more. This in turn increases a student's competence and confidence, and all the while providing a much more engaging learning experience.